Hello, this is our second video tutorial on solving equations using sketching. And the last one I realized was a little bit longer than I like, so this one's going to be shorter, but I was trying to make sure y'all had enough examples to get started. This time we're only going to do 2 examples because they're both going to be about the next level when you have both variables and constants on both sides, like you can see in both of these problems. And I'm going to do the one that's highlighted, problem number 1. So the first thing I'm going to do is draw my line. And I'm just going to start with the sketching. It starts off with 2 x's. Remember, x's are triangles. So I'm going to do 2 triangles. And then it's got a 2 constant, a 2 without a letter, so that's a 2 cube. Then on the right side, there's no number in front of the x, so we can put a 1. So that means I have 1 x, so 1 triangle. And then a 5 without an x, so that's just a 5 constant, which is a 5 cube. Okay, that's the basic sketch. That's all I need. Now I need to start solving it. And if we can remember what we learned last time, you can take off things from both sides. We should always start with the triangles, which are the x's, because we always want to get the x's by themselves, and we always want, if we can, just to get one left. So I notice that I have triangles on both sides, so I can take off triangles. I have to take them off from both sides, and I have to take off the same amount. So what I can take off is I can take off a triangle from the right, but then I also have to take off a triangle for the left. And if I do that, I notice now I don't have triangles on each side anymore. So I can't take off triangles. That's it. That's all the triangles I can take off is one on each side. So what I have left, I'm just going to do another line of what I have left. I have this 1 triangle here on the left, and I have this 2 cube on the left. And then on the right side, I have this 5 cube. So that's what's left after I took off 1 triangle from each side. But I also noticed that I have cubes on each side. So just like you can take off a triangle from each side, you can take off a cube from each side. But you have to be very careful about which one you want to take off, because you want to take off one that helps you. Well, the thing is we always want to get the triangle, I'm highlighting it here, by itself. And right now it's not by itself, it's got that 2 cube with it. So if I take away that 2 cube, now that triangle is left by itself. But if I take away the 2 cube from the left side, I have to take it away from the right side. So take away is a subtract. So I'm going to say subtracting the 2 cube. And then what I have left is 5 cube minus 2 cube gives me a 3 cube. And on the left side, I've got that 1 triangle left, which is what I wanted. So yay, I'm pretty much done, because I know what 1 triangle equals. It equals a 3 cube, or like its points. So that means x just equals 3. Now if I want to check it to see if I'm right, and I do, I'm going to go back up here, and I'm going to erase this step, and I'm just going to remember that a triangle equals 3, just like an x equals 3. I'm going to go back to where my triangles were, because originally, in fact, I'm going to erase these little marks here, because originally what I had was 2 triangles and a 2 cube, and 1 triangle and a 5 cube. Now I'm going to substitute back in this 3 where the triangles are. So I have a 3 for that triangle, a 3 for the second triangle, and that 2 cube. That is what the point value of my left side. Then I'm going to go to my right side. I'm going to put a 3 in for that triangle, and I have a 5 cube. And remember what we're doing is we're adding. So if I say this 3 plus the next 3, 3 plus 3, that's 6, plus that 2 cube, okay, gives me 8, because 6 plus 2 is 8. So I have an 8 on my left side. And if I look at my right side, I have 3 plus a 5 cube, that's also 8. So I have 8 on my right, 8 on my left. That balances. That means my answer of x equals 3 is correct. I've got the correct solution to this equation. 3 is the number that exists that makes the left side equal to the right side or balances the equation. Okay, now I'm going to look at the next example, and I'm going to skip down in our notes to example number 4, and that's the one I'm actually going to do. So I'm going to draw my line. I'm going to start off with my sketches. I've got 3 x's here, so I'm going to do 1, 2, 3 triangles, and a 7 cube. On my left side, on my right side, I'm going to do 5 x's, so 1, 2, 3, 4, 5 triangles, and a 1 cube for that one constant. Okay, now again, I'm going to start with triangles. If you've got triangles on both sides, we always start with triangles. We can take off. And I can do them one at a time if I want, or I can realize that I've got 3 triangles that I can take off of the left side, and I have enough to take off 3 on the right side. So if you kind of want to do it in one step, you can, or you can do it one at a time. You just have to make sure that you take off the same on both sides. In this case, I took off 3 triangles from both sides. Now what I have left over is I've got this 7 cube, this 7 constant on the left side, and on the right side I've got these 2 triangles, which are 2 x's really, and a 1 cube, which is a 1 constant. So I'm getting closer to getting my triangles all isolated. I've got them together, okay, so I have just 2 left, but I don't have them completely isolated. But what I notice is that I have cubes on each side, so I can take cubes off. I just have to take the same amount from both sides, and I have to pick the side that would help. If I want to get my triangles here by themselves, then I need to take off this 1 cube. So that's what I'm going to do. I'm going to take off this 1 cube, and when I take off that 1 cube, that leaves these 2 triangles all by their lonesome self, which is what I want. But if I take off 1 cube from the right side, I have to take off a 1 cube from the left side. So over here, I'm going to go over here, and I'm going to do a little minus a 1 cube. Real kind of tiny, squeeze it in, but we can still see it. So what I have now is I have a 7 cube minus a 1 cube. That's going to give me a 6 cube because 7 minus 1 is 6. Now there's nothing more I can take off because I don't have triangles on both sides anymore, and I don't have cubes on both sides anymore. So that's it. But I'm at a good spot where I can sort of do that guess and check, because I need to figure out what number I can put here and here that when I add them together, I get a 6, and that number happens to be a 3. If I put a 3 here for this triangle and a 3 here for this one, remember it has to be the same. And I can say, okay, 3 plus 3 is 6, and I needed it to equal 6, and it did. So I've got the same number on both sides, so one triangle must equal a 3. Or you can write it the other way. Doesn't matter. So if a triangle equals a 3, that means x equals 3. Now, if you want to check your answer, which I do, I always want to go back and check, because I would like to know that I got it right after doing all that work. I'm just going to erase that so I can remind myself what it is, and I'm going to erase these little lines here because I've got to remember that those are actually part of the original equation. Go back to the original. And so every place that there was a triangle, here, here, and here, I'm going to put a 3 on the left side because I remember that a triangle equals 3. It's the same thing as x equals 3. I'm going to put those there. But I also have that 7 cube. So I'm going to put it there. I'm going to remind myself it was just a constant. And then I have 5 spots on the right side where I need to put in the 3. So 1, 2, 3, 4, 5. And then I've got to remember the 1 cube. Now I've got to think about adding them all back up. So 3 plus 3 is 6. 6 plus 3 is 9. And 9 plus 7 is 16. So I've got 16 points. Now I'm going to go to the right side. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. And 15 plus 1 is, yay, 16. So it balances. I've got 16 on both sides. That means that this x equals 3 was my answer. I got it correct because it balanced on both sides.